So here we're going to do problem 71 from chapter 3. This problem, it says that there is a diver who is going to jump up in the air. Their initial speed is going to be upwards at 4 meters per second. They're going to go up in the air and then come back down. And we're told that the initial height is 1.8 meters above the water. So we're going to say this is, say, the x0 level. We're going to call up the positive x direction if we're going to work in these coordinates. And we'll say that down is the acceleration, so down will be, the acceleration will be minus 9.8 meters per second squared. And we have a number of questions that we want to answer. So the first one is, how high is she before she cuts down? So in part A, up here, the speed is going to be 0 at the top. And so we can use the equation v is v0 plus 2a, v squared is v0 squared plus 2a delta x, oops, not squared, in order to find how high she is when she gets from the top. And so at the top, her speed is 0. When she leaves her board, her speed is 4. We picked up to be the positive direction, so I'll use negative 9.8 for the acceleration. And delta x here will represent the height above where she starts when she gets to the top. And so delta x is minus 16, that's 4 squared over 2 times negative 9.8, and that works out to be 0.8163 meters. So that's how far it is to the top. And I'm keeping a couple extra digits here just to, because I'm going to use that answer in the next parts. So in part B, we're asked to find the total time that we're in the air. So the total time in the air, I'm going to break into two parts. I'm going to say it's going to be the time to the top, because that's not too hard to find, plus the time to fall from the top to the water. So the time to the top, I'm going to use v is v0 plus at. So at the top, her speed is 0. She's leaving the board at a speed of 4. The acceleration is 9.8 with the minus sign times time. So the time to the top, if we put in those numbers, works out to be 0.408 seconds. And then once she's at the top, so here's the board, this is 1.8 meters. This distance here is 0.8163 meters. So she's here and she's going to fall down towards the water. So at the top, I'm going to switch to thinking about the top as the initial place. So if at the initial place at the top, she's at a height, an x0 of 1.8 plus 0.8163. And the speed at the top now is 0 meters per second. So I'm switching what I'm calling v0 from the place on the board to the place at the top. And the reason I do that is that I know that she's going to hit the water eventually. And now I'm thinking about this is just the time as she's falling, so eventually she'll get to 0. She's going to start at the sum of these heights, and the sum of these heights is 2.61. We'll use that many digits. 0 times time plus a half times negative 9.8 times time squared. So this 0 times time here gets rid of that term, so I have just, my time is just over there. And so I find that that time is 0.731 seconds. And so the total time is 1.14 seconds. And then in the last part of this question, we're supposed to find the speed that she's going when she hits the water. So in part C, if I want to find the speed, I can do v is v0 plus at. And again, I'm going to think as from the total top, where her speed is initially 0, And I'm going to use this time to be 1.14 seconds, which is the time that I had previously. And so the speed when she hits the water is 0 minus 9.8 times 1.14. And so for that speed, I get negative 7.16 meters per second, where the minus sign means that she's going downwards when she hits the water, which obviously she is.